Good afternoon and welcome to the Washington State China Relations Council's webinar on the important role of semiconductors in the U.S. China relationship. I'm Man Wang, director here at the WCRC. Semiconductors have been at the center stage of U.S. China technology competition. A lot has happened in the past 3 years. During the trade war, the Trump administration sought to prevent the sale of key semiconductor technology to Chinese companies, notably ZTE and Huawei, citing national security concerns. The pandemic exposed the frailty of semiconductor supply chains, with many industries that rely on chips, such as automakers, hampered by the lack of supply. In 2021, the Biden administration, in its 100-day review of supply chains, identified semiconductors as among 4 key areas of national security. The recently passed CHIPS and Science Act, signed into law in early August, allocates $52 billion for semiconductor manufacturing, R&D, and worker training, along with restrictions on investments in China for firms receiving subsidies. China, meanwhile, despite many tens of billions of dollars invested in its domestic industry, has not yet seen the advancement the leaders had hoped for. The semiconductor industry is also tangled with tensions in the Taiwan Strait. Taiwan controls over 60% global market share in chip manufacturing, and an even greater share of the most advanced chips both the U.S. and China are striving to gain an advantage in. So today, we're delighted to have a recognized expert in global technology policy, Paul Triolo, to help us better understand the topic. Paul is the Senior Vice President for China and Technology Policy Lead at Albright Stonebridge Group, where he advises clients in technology, financial services, and other sectors as they navigate complex political and regulatory matters in China and around the world. Paul was most recently founder, practice head, and managing director of the geotechnology practice at Eurasia Group. Previously, he spent more than 25 years in senior positions in the U.S. government, analyzing China's rise as a technology power and advising senior policymakers on a broad set of technology-related issues. At the beginning of his career, he worked as an engineer for a semiconductor testing firm in Silicon Valley. Paul is also a senior associate with the trustee chair in Chinese business and economics at the Center for Strategic and International Studies, a senior advisor at the Paulson Institute, and is a life member of the Council on Foreign Relations. Paul, thank you for joining us and for sharing your insights with our audience.
What a pleasure. Glad to be here.
Thank you. Our moderator or interviewer today is Noor Kokiart, the executive director here at the WCRC. Noor spent over 30 years in Asia serving as business executive, mostly at Cargill, and 18 of those years were in Shanghai. During that time, he also held numerous positions in business associations, including serving as the chairman of AmCham Shanghai from 2008 to 2009. So for today's program, after the moderated discussion, we'll turn to the audience for questions. If you have questions for our speaker, please type them in the chat box, and we'll try to collect and address them all during the audience Q&A session. And before turning the floor to Noor, I'd like to mention that we'll have a webinar this Wednesday on another important topic, the Uyghur Forced Labor Prevention Act. Our panel includes seasoned attorneys and logistics experts who work with clients closely on the regulations. And so details about this event can be found on our website. Please take a look, and we hope you can join us. So Noor, over to you.
Okay, thanks, Mon, and welcome everyone to today's webinar. First of all, I didn't realize it would be in competition with a rocket crashing into an asteroid, which apparently is supposed to happen in 6 minutes. So if anybody's watching on their other computer, let us know what happens.
That's how it goes. Yeah, we need to look up.
Yeah, hopefully we're not impacted. The Earth is not going to be impacted by this. Okay, I want to thank Paul for agreeing to talk to us today. I think it was in the early days of the pandemic, maybe within the first 6 months of the pandemic, that I I was listening to maybe 2 webinars, 3 webinars a month on China-related topics, and I did hear Paul talk about semiconductors. And I thought at that point in time, this guy has made the clearest presentation of what how semiconductors are so important in the world economy today and how they're impacting the China-U.S. relationship. So I said, we got to get this guy to talk to the Washington State China Relations Council. So fortunately, I saw Paul at a conference this summer, said, would he please talk to us today, and he agreed to do it. So I'm really glad that we have him today as our guest. So Mon outlined today in her opening comments about how important semiconductors are in the world economy and how and the role kind of they play in the fractious U.S. China relationship. So we'll get right into questions with Paul, and then as Mon mentioned later on, we'll get into audience Q&A. So Paul, let's get started. My first question would be, in the past couple of years, commentators have likened semiconductors to oil, the commodity that dictates world markets, a product that impacts us all in a very substantial way. So really, what's happened? I mean, 5 years ago, the average person wasn't talking about semiconductors. So why are we having this conversation today?
That's a great question, Nor. So I think, in one way, the oil analogy may not be that that relevant, but I think in another, it is in a sense that semiconductors sort of underlie all these things that we sort of take for granted and do. I think the pandemic in particular brought forward sort of the importance of the issue, even as it was in circles of people who cover China and U.S. relations. It was obviously semiconductors were a big issue, but I think for the general public, it was the pandemic and the shortages of certain types of semiconductors that affected the auto industry and medical devices, et cetera, that sort of brought this issue to the fore. People were losing their jobs in Detroit, because there were not enough semiconductors, et cetera. So then it became clear that, wow, semiconductors underlie our play online, our education online, data centers are all driven, critical users of semiconductors. And then things like autonomous vehicles, smart things that are increasingly all around us, of course, rely heavily on very specific kinds of semiconductors. And so I think that if anybody who has a smartphone, of course, is holding in their hand hundreds of semiconductors that are all chocked full of, these phones are chock full of them, that are all really enabling an amazing amount of sort of computing capacity at our fingertips, and that's because of the innovation and the ubiquity of semiconductors. So I think people sort of it's the kind of thing where you sort of take it for granted because it's everywhere, but when there's a shortage or when there's a crisis or there's U.S. China relations get bad and semiconductors at the center, people start taking notice. So I think that's one of the big issues. I think, and in the introduction we heard about the fragility of supply chains. I think that's true. The other piece of it, which we'll get into, is the sort of the 30 or 40 years of optimization of global supply chains around semiconductors, and the sort of geographic concentration and division of labor we've seen just means that everybody woke up one morning and realized that Taiwan was a really critical piece of this whole global story, and in particular one company, TSMC, Taiwan Semiconductor Manufacturing Corporation, which again in the industry well-known business model and well-known as a critical player, but the fact that they are making 92% of the most advanced semiconductors suddenly became a really big issue, sort of geopolitically, if you will, and then also during the shortage too, because they were also involved in helping to fix the shortage, or in some cases, trying to compensate for some of the other companies. So I think that all these things kind of came together in the last 3 years: the pandemic, U.S. China relations, and the willingness of the U.S. government, in some cases, to weaponize U.S. dominance of some of these critical areas of semiconductors, all to sort of bring semiconductors to people's consciousness in a way they hadn't really been before.
So before we get too much into this, you mentioned smartphones, and we're going to talk about semiconductor sizes, et cetera. So what's the size of a chip in a smartphone?
Well, we talk about feature widths, line widths. This is sort of the space between the the smallest features on a chip, the transistors. If you're using an iPhone 14 Pro Max, you're probably holding at least a 5. The most important chips in there are at the 5 nanometer level. Apple will probably soon be using 3 and 2 nanometer chips. So a nanometer, it's like the width of way less than the width of a hair. So the feature size is very small. The most important factor there, though, is sort of the power consumption and the throughput to the sort of the ultimate computing power, and the sort of the packaging. And then in your smartphone, there's many types of chips beyond sort of the core system on a chip, for example. That might be manufactured at TSMC. There's memory. There's GPUs. There's all sorts of AI processors in there too. So there's lots of different discrete semiconductors in your phone. But the commercial market, and smartphones in particular, are driven by the cutting edge. Other areas are not so cutting edge, as we saw with the shortage, like automobiles use a lot of really, low legacy, low tech chips like controllers that actuate your door and other pieces, and those are not as advanced.
What size would those types of chips be?
Those might be 45 nanometers or 90 nanometers, or pretty big. I mean, it sounds small still, but there's a huge difference, of course, between a 90 nanometer chip and a 2 nanometer chip, and just in terms of the processor technology to get commercial yields for those very advanced chips. So when we say legacy, is usually people talk about things like 28 nanometers and above is sort of legacy. There's no, the definitions of these are tricky. In fact, I think in the introduction, she mentioned the CHIPS Act. And of course, that originally, the focus on that was very much advanced semiconductors of the type that TSMC is manufacturing for Apple and Qualcomm and others. But the first probably 10 billion, and at least a chunk of the first 10 billion is of that what is really 39 billion in subsidies, will go for legacy chips because of the chip shortage. So for things like controllers and RF chips and other things that are not as advanced. So that's an interesting twist on that. But yeah, I mean, the bottom line is that an advanced device these days, like a smartphone, has a range of technologies in it. But the most important part of it, if you don't have the advanced sort of cutting edge chip, then everything else doesn't work as well together. That's what happened, of course, to Huawei when they were cut off from manufacturing those most advanced semiconductors. At TSMC, their smartphone sales fell off a cliff, and they had been headed to be global leaders, competing with Apple and Samsung. But since they couldn't get those very cutting edge chips, they're sort of forced to figure out other ways to compensate for not being able to manufacture those. So that's a big deal. But for other systems, you don't need, it depends on the system in terms of what level of technology you need. It's not always the most advanced chips, but those tend to get a lot of attention. And they got a lot of attention, for example, for the CHIPS Act.
Right, yeah, and the 5 nanometers is a number I keep hearing thrown around. I had no clue that the Apple phone has a 5 nanometer or smaller chip in it. Okay, so you just gave us a little bit of the technical understanding of the industry. Can you give us kind of the broad geographic kind of play? Who are the major players? What are the major countries that are playing? What's kind of the supply chain look like before we get into more detailed discussion?
Sure, yeah. I mean, that you have a lot of different pieces when people say semiconductor supply chain. There's lots of different pieces to it. So I think it's a sort of, we usually talk about production, and then you can talk about sort of upstream and downstream kinds of things. So the big sort of advanced producers, of course, that are producing at the cutting edge, and maybe the second tier, are primarily located in Asia, right? So Japan, South Korea, Taiwan, and China is really where most of the cutting edge chips are made. And then you have a lot of other sort of second tier players. In Europe, you have NXP, for example, and Infineon, and some smaller players, STM Microelectronics. So Europe right now has about 10% of global capacity, for example. The US has about 10% too. Of course, you have Intel in the US, although it doesn't manufacture that much in the US, a lot of it is overseas. But you have US at about 10%, Europe up at about 10%, but then the bulk of the real capacity then is in Asia, a little bit in Israel, Israel has a little piece of that. So then you talk about things like let's say upstream. So you have all the inputs into those manufacturing facilities that are located in these countries. And again, there's some specialization. For example, South Korea tends to dominate in memory. You have SK Hynix and Samsung, for example, which dominate in DRAM and 3D NAND memory that's used in your phone and used for things like data storage and data centers. So for various reasons, South Korea dominates memory. But logic, we talk about logic, that's what we're talking about, sort of the chips that are driving your phone. That's definitely Taiwan. Again, Samsung and South Korea also does logic, and then China and Japan to some degree. So then as you look upstream, you have the inputs, you have the manufacturing tools. There, the U.S. really dominates. U.S., Japan, and the Netherlands, for example. So there's some niche players in that space. The tool makers, the people who make the tools to make the semiconductors, that they're really just U.S., Japan, and the Netherlands that are the primary players here. The U.S., most big U.S. companies like Applied Materials, KLA Tenko, or Lam Research, they have about 60% of some of the key tool markets that are key inputs to there. But then there's things like process gases and all sorts of materials you need to make semiconductors. And Japan is a big player in that. Even Ukraine, for example, was a source of some gases, neon, and some of the gases that you need in the production process. So there are other players that sort of specialize. Russia, actually, also a player in some of the minerals and gases you need. So upstream, it's a little bit more diverse, although if you look at just the tool sector, it's really dominated by the US. Then downstream, you look at things like packaging and testing, which is really critical, right? And that's, again, Asia, Taiwan, China, really dominate that area. And that's one of the areas the CHIPS Act is trying to change, for example, because if you're going to do advanced manufacturing in the US, you're probably going to need advanced packaging to go with that. You're not going to be wanting to ship stuff back to Asia, and that also goes with the upstream stuff too, right? You don't want to ship everything from Asia to the US, manufacture, and then ship everything back to Asia and then ship it back to the US. So there'll be a lot of change in the way those supply chains work as a result of things like the CHIPS Act and some of these industrial policy moves we're seeing from the Biden administration. But basically, over the last 30 years, the industry has developed these sort of geographic concentrations, in part just based on the fact that a company like TSMC, for example, that their business model, the foundry model, just proved to be really, really good and innovative, and so they ended up dominating the manufacturing side at the advanced nodes because they focused their efforts on that. They have a lot of smart engineers, a lot of government support and subsidies. And then they kind of got economies of scale to the point where they were just really, it's very hard to compete with them. And then in areas like process gases, the Japanese companies are proved to be really capable and sort of dominate that part of the supply chain. So supply chain is global, but it is sort of clumpy in the sense that it has these areas where different countries provide different have companies that dominate. The other piece of it is that in terms of subsidies, before the CHIPS Act, which was again mentioned earlier, many of these other advanced countries, developed countries like Germany and other countries in Europe and Israel, even Taiwan, South Korea, Japan, all subsidized to some degree their domestic semiconductor industry. So in a sense, the US is now again coming back around to an industrial policy that will assist both U.S. companies and other companies that want to onshore here with subsidies. Because the other issue here is that the industry, at least and particularly the production side and the cutting edge, is very, very capital intensive. And so if you want to make that 2 nanometer chip, you're talking about a $40 billion investment in a fab. So the U.S. is sort of jumping back into the industrial policy game in the semiconductor industry at a time when, if you want to play at the cutting edge, you're talking about significant amounts of investment and capex and sort of long lead times and amortization times to recoup that investment. So that's so the industry is really in an interesting juncture where governments now, because of some of the issues we'll talk about geopolitically, want to have more say over that supply chain, in part because of the shortages that we talked about earlier, but just also because of the concentration that we've seen, particularly in geopolitically fragile areas like Taiwan and South Korea.
So a couple of things. I always thought testing and packaging was like test out the chip and put it in a box. But from what I just listening to you, packaging is putting it together on a board to work with the other with GPUs to put it together to make the thing effective. Is that correct?
Well, it can be many things. It can be testing the actual whatever assembly you're talking about. Yeah, it could be the chip itself. It could be the chip with other chips, or it could be a larger package, a board level test, for example, that's of a server board that includes multiple semiconductors. But usually you think of things like individual chip packaging and testing. You have to make sure those chips work. Now, a lot of companies specialize in testing. I used to work for a company, for example, that tested semiconductors. So that was just basic functionality. Make sure that the chip works, all the specs and all the instruction sets and everything work according to what you're claiming is the capability of the chip. You got to test that, and you got to do it. You got to do it quickly. And if you're talking about millions of semiconductors, and then the packaging again depends on sort of the final destination of the chip, and that's where Taiwan and China are very critical. Almost all the world's electronics are eventually assembled in China, right? So they might be made in Taiwan at TSMC, tested and packaged at one level in Taiwan, and then shipped to China for incorporation into larger things. That was one of the problems with that was difficult for the U.S. government to understand when they came up with the sworn direct product rule, for example, with Huawei. So initially the thinking was that Huawei sends chip designs to TSMC, and TSMC builds the semiconductor and sends it back to Huawei. But it was much more complicated than that. In some cases, Huawei never saw that they sent the chip design to TSMC, and they never actually saw the final product. It would be packaged and tested in Taiwan, then it would go to another assembler, and then a contract manufacturer in China or in Taiwan would manufacture it, and then the end product would be shipped directly to the consumer. So it was that's the way the industry sort of works, specialization in these areas. So the packaging testing part is important, but we're now moving into a new era where with things called chiplets, where there's going to be multiple different types of semiconductors at different nodes, for example, all packaged in one package. So you could have the die or a package that includes a really high-end CPU and includes other chips that do various specialized tasks and memory all in one package. So the industry is moving towards that, and that kind of advanced packaging is an area where the U.S. will be looking to get. U.S. and Japan will be looking to also play bigger roles going forward. So packaging testing is really, in terms of driving the industry forward and getting more capability and functionality out of the semiconductor package. The packaging now is becoming really important to keep Moore's law going. Moore's law, right, is the doubling capacity and the reduction of cost. So we sort of we're nearing the end of that Moore's law in terms of the actual semiconductor. So now to get the capability, we're moving into a new era where packaging is going to be even more important, and how that's done effectively.
Okay, before we move on, you talked in broad terms, but can we put kind of some numbers on the manufacturing? From what I understand, Taiwan's about 60%. Is that right?
I'm not sure that's right. No.
Okay.
What I have to distinguish here between foundry. So there's two models in the manufacturing side. There's integrated device manufacturers. Think of Intel. Intel makes designs and makes its own CPUs for sells those. Okay, so that's an integrated sort of approach. On the foundry model, which is what TSMC pioneered, they're focusing just on manufacturing. They're taking the designs of Apple and Qualcomm and Nvidia and all the big companies. Many companies in China too are using TSMC. Many companies, and then they do the manufacturing and then send the product back to the original company. So Taiwan has over 50% of the foundry market. And then of that, if you look within that, 92% then of that is the most advanced nodes. But if you look at sort of the overall manufacturing capacity, Taiwan is much lower because, think of all the semiconductors. You have memory makers, for example, in South Korea. Taiwan has some memory companies like Nanya, but they're not a huge player in the memory space the way South Korea is, and even China now is becoming. So it's really, so when you talk about, you have to sort of talk about the different subsectors of semiconductors to talk about sort of the gross picture. So when I gave that figure of 10% in Europe and 10% in the US, that was sort of capacity, overall semiconductor manufacturing capacity. That includes everything, memory, logic, everything. But if you're talking about Taiwan, the real issue with Taiwan is this dominance in the foundry part of the business, because that's sort of where the industry is going. Everybody wants to design now their own semiconductors. Apple, for example, is designing the M1 and M2, which are going into their new laptops. Those are designed by Apple, but they're manufactured in Taiwan. Tesla, think of Tesla. If you drive a Tesla, your ASIC, your application-specific integrated circuit, in your video card in there that's driving the AI, your full self-driving, that's an ASIC that's manufactured probably in Taiwan by TSMC.
But designed by Tesla?
Designed by Tesla, absolutely. Made there. So that's where the issue is. Taiwan's dominance is in the foundry side of things. But if you look at the whole market, Taiwan's percentage of global semiconductor capacity is much less, maybe, I don't know, 10 or 15%. But in that specific area of advanced semiconductors and foundry production, that's where Taiwan really becomes the dominant player.
Okay, and I mean, you've talked a lot about Taiwan already, but how did Taiwan get to be the dominant player? You touched on a little bit, but yeah, tell us a little more.
It's a long story. No, but it's basically Morris Chang, who worked at TI, studied in the U.S., went back to Taiwan, and he I guess had the vision that it might be good to specialize in manufacturing, because companies, as semiconductors became more and more complicated and more stuff was crammed onto a particular wafer, it became harder for companies to do that, to all be manufacture their own stuff, right? Design and manufacture their own stuff, because it became more and more capital intensive. And so his vision was that to see that, hey, the industry would be much better served if companies like TSMC specialized just in the manufacturing, and then outsource, the companies could outsource their designs and their manufacturing. And so it turned out that model is really, really powerful, because TSMC is in a trusted position working with both upstream clients like tool manufacturers and pushing the cutting edge on development of new tools, and then with the downstream clients designing their designs, and also if they have really advanced designs, figuring out how to get the right tools to do the manufacturing. So what's driven innovation in the industry over the last 20 years in particular is this foundry model, and the sort of trust. Taiwan ended up having, there's a trust in the system. TSMC has great customer service and intellectual property protection, et cetera. And so that model has just proven to be really, really powerful. So companies like Intel, which stuck to the IDM, the integrated device manufacturer model, Intel is a great company, right? They still dominate in terms of CPUs for cloud servers, for example. The Xeons that Intel makes are still dominate. They have a huge chunk of that server section, but they didn't get into, for example, of these other areas like GPUs, which they're trying to get into now. And then they're also realizing that the foundry model is so important that the new CEO, Pat Gelsinger, has come in, and now there's something called Intel Foundry Services, and they want to get into that game, because that's sort of where the industry is mostly headed. Because, as I say, all these companies want to design their own chips, and they're going to use whoever's the best at manufacturing those at the most advanced nodes, if that's what they need. So TSMC model just proved to be really good, and they proved to have really good, engineers in Taiwan, and also these economies of scale. That's the other piece of this, that they're so successful, and it's going to be difficult for the U.S. To reproduce if the U.S., as a result of the CHIPS Act, wants to onshore some of that manufacturing. Because in Taiwan, you have the TSMC running, for example, 20 gigafabs, all within a fairly short geographical area. So they can optimize, they can send engineers out to troubleshoot things. They also recruit, for example, some huge 60% of all the STEM graduates, PhD graduates in Taiwan go to work for TSMC. I think they ran the numbers out to 2030. It was going to be like 85%. And so they have a really good education system. They produce hardware engineers, and it's sort of sexy to work for TSMC. TSMC is like 15% of the GDP in Taiwan. And so TSMC has this very dynamic model that has just proven to be really, really what the industry wanted in some sense. And so that's why they're dominant in that area. And then other companies like Samsung, the only other companies, Samsung and Intel, that can really compete, they're coming from this more IDM, this integrated device manufacturer model, and trying to get into the foundry model. And they will succeed in some areas, but TSMC has just proven to be such a good and powerful and successful and reliable company. They produce at high yields, and you can kind of count on, if you have a design that's really complicated and hard, they're going to be able to build it, and they're going to be able to scale it up, and the quality is going to be good, and you can trust that they're going to succeed. So they've just established a sort of a name in the industry that it's really hard to compete with.
And I think it may have been you, it probably was you. I think we talked one time and said if the U.S. was going to have cutting edge semiconductor technology or produce them in the U.S., they'd probably have to, Intel or somebody would have to license the technology from TSMC. Was that?
Well, no, not. I mean, that's it. Intel may end up having some ability to do that. But what the thrust of the CHIPS Act, which is
my next question. So yeah, go right ahead on the CHIPS Act.
And we have a lot of clients that are interested in understanding the CHIPS Act. So I just wrote a 15-page memo on the CHIPS Act today, as luck would have it. But the CHIPS Act, this is just to step back a minute. I mean, why do we have the CHIPS Act, right? So as I mentioned, U.S. was one of the few countries that did not subsidize a semiconductor industry. So a lot of semiconductor manufacturing went offshore, and went to Taiwan and went elsewhere. Intel, of course, is still the U.S. national champion. It's a great company. They do manufacture quite a bit in the U.S. and they have facilities overseas also. But Intel sort of fell behind the technology curve when they've had some trouble mastering the latest technology for advanced manufacturing, extreme ultraviolet lithography, UV. And so Intel has sort of fallen behind the curve a little bit. So all of a sudden in 2018, 2019 timeframe, the U.S. government woke up and realized, oh my God, we don't have a national champion that's at the cutting edge anymore. We're now reliant on TSMC for 90% of advanced manufacturing. And then the other key piece, though, is that the realization that China at some point would seek reunification with Taiwan, either peacefully or by force. And I think that also concentrated minds to say, hey, we better start changing that equation by attracting companies to build manufacturing facilities in the U.S. as part of this broader supply chain issue. The chip shortage sort of brought that home also. So in the 2018-2020 timeframe, we had the development of the CHIPS Act. And this was designed to be sort of a down payment for the longer term development of a U.S. domestic advanced manufacturing capacity and capability. And so TSMC early on agreed to site a facility in Arizona, which is under construction even as we speak. That's a 5-nanometer facility in Arizona, which will begin production probably in the 2024 timeframe. And the hope, of course, is that TSMC will then bring its more advanced node processes, 3 nanometers, 2 nanometers, eventually to Arizona, in the out years, 2025, 2026, 2027, although that remains to be seen, because TSMC, probably given its own druthers, would prefer to just stay in Taiwan, right? Because they have so many advantages there in terms of understanding the system and getting subsidies and knowing how to expand capacity judiciously within their commercial business model. So the problem with the U.S. and the CHIPS Act is, everybody agrees it's a good idea to do this. The problem is sort of what is the end goal here, right? I mean, that 92% figure I talked about, even if the U.S. builds, if Intel builds the 2 facilities that they're planning to do in Ohio, if TSMC builds a gigafab in Arizona, and if Samsung builds an advanced facility in Texas, then probably by 2030, maybe that 92% will go down to 70% or 75%, right? But it's still going to be a pretty huge dependence. So the problem is, as I noted earlier, the U.S. is sort of jumping into this industrial policy and subsidies game at a time when the concentration is pretty big already in the industry, and the cost of building these advanced fabs is really really heavy. And then in addition, you need these sort of clusters. You need what the industry has developed is around clusters. So in Taiwan, you have not only the manufacturing facilities, but you have all the support facilities, all the supporting companies that provide the process gases and provide the packaging and testing. They're all sort of concentrated in a smaller area. So probably in the U.S., what we'll have under the CHIPS Act eventually is clusters in Texas, around Austin with Samsung, and in Arizona with TSMC and Intel, and in Ohio with Intel around Ohio State University there. So and then in New York, also in Albany with the one of the R&D centers that the CHIPS Act also provides funding for, which will be an advanced packaging and testing operation in New York. So the goal of the CHIPS Act is to sort of jumpstart the U.S. Onshore advanced manufacturing industry, and so the administration right now is gearing up heavily for the first round of applications from companies that will be applying for funding under the CHIPS Act. But it's going this is a long-term effort here. This is like a 10-year minimum effort to try to really change that geographic concentration and really reduce dependence on Taiwan. So really the CHIPS Act is more. It's not really about competing with China. I did a piece for Kaiser Kuo at the China Project, which said really, it's not, because it was spun a little bit as if it's competing with China. It's really about reducing that dependence on Taiwan and providing, for example, domestic advanced manufacturing for U.S. government, for the Department of Defense, for example, which relies on companies like TSMC for advanced manufacturing for some of its semiconductors. And so I think the big worry was that we'd wake up in 2027 and Xi Jinping would have decided to take Taiwan by force, and we could talk about whether that's a good way to look at the problem. But that certainly was one of the drivers of the CHIPS Act, and now the U.S. government is moving ahead with this. There, of course, is a lot of skepticism in Taiwan and among Morris Chang in particular about the long-term commitment of the U.S. government to subsidizing and really fostering an ecosystem that will allow this kind of manufacturing to occur in the U.S. at scale. Morris Chang said, it could be this big boondoggle, right? A big waste of money, because he's skeptical whether the U.S. government is committed to this. And there are big issues around, personnel, STEM graduates. How do you get sufficient people that are trained to be hardware engineers to run these facilities, for example? You need a lot of people to do that. TSMC is already training some U.S. engineers in Taiwan. And the CHIPS Act does have a provision in there for workforce training. And so all the companies that are applying for money, for example, will have to also discuss how they're going to help improve the U.S. workforce to support these facilities. Because once you let all the stuff go offshore, then you sort of lose the ability to have a sufficient pool of trained people to run these things. These fabs are they're some of the most complicated things that humans do on the planet, and so to run, you need really, really good people and a certain critical number of them, and then all the supporting companies need sufficient engineers too. So it's a very non-trivial problem to sort of try to onshore multiple pieces of the supply chain, along with getting sufficiently trained personnel to run them. But that's the project that the U.S. government is embarked on right now.
Yeah, just a quick aside. I have a friend who's trained. He's maybe 5-6 years out of graduate school and to be a high-end semiconductor engineer, and has not been able to find a decent job in the U.S.
Well, tell him to go to Arizona and apply with TSMC, because
with the CHIPS Act coming, I think that's
they're recruiting
right.
heavily, right? Yeah, and the CHIPS Act has been passed, and so the workforce training is maybe the most important part of this, because if that doesn't succeed, then the whole is sort of in jeopardy. Commerce Secretary Gina Raimondo has really emphasized the need to look at the CHIPS Act sort of holistically, right? Yes, it's about advanced manufacturing, but it's really about building an ecosystem in the U.S. Of which the most critical part, arguably, is talent and engineering.
And on the CHIPS Act, it's $39 billion initially to subsidize plants. Yeah,
it's now $30 billion up until 2026. So. Okay. Be $30 billion for advanced node manufacturing and roughly $9 billion to $10 billion for legacy manufacturing. And then in 2026, Congress will have to decide, whether to renew that or to pass subsequent funding bills, because as I noted, TSMC is building the fab in Arizona, the 5-nanometer fab. If they're going to be encouraged to build, expand capacity to 3 and 2 nanometers, they're going to need new subsidies for that, because again, if you say like a $30 billion fab, usually 5 to 7 to 8 billion of that comes in the form of subsidies. If you're in Taiwan, for example, the government will provide in terms of tax incentives or land or other kinds of incentives. So usually that makes a huge difference, right? That 8 billion out of say 30 billion, if 8 billion of that is subsidized, that makes the whole economics of a fab work. The costs in the U.S., of course, are much higher than in Taiwan too. That's the other thing. The cost of building, the land, the power, it's all much more expensive. Engineers are more expensive. So it's going to be a challenge to make all this work from a sort of commercial point of view. That's again why TSMC executives are skeptical, at least, or making noises about whether they're really they really see this long-term commitment. It took 2 years to get the CHIPS Act through Congress, right? Because it got caught in a lot of political gamesmanship between the Republicans and Democrats. Everybody thought it was a great idea, but the details ended up being tricky, and then they included a lot of things. I think again, was mentioned earlier, things like the guardrails package, which restricts the companies receiving CHIPS Act money, for example, from expanding facilities in China. That's another big thing we should probably talk about. So anyway, so it's on the one hand, it's a great thing, right? The people I was talking to today, we're all excited about it, and we have a lot of clients coming in interested in how they think about navigating the process of applying for CHIPS Act money. But the U.S. government is going to have to step up, put in place a structure in the Commerce Department under NIST, the CHIPS program office, for example, and staff that with people who really understand the industry well, which is tricky. Because those people are in demand, and it really is a holistic thing. Gina Raimondo has been stressing this, the Commerce Secretary, and so the people that they're looking for are people who understand, the geopolitics of the industry, the technologies, the companies, the supply chains. When it comes down to it, it's a pretty complicated industry, and so you need to have a nuanced and sort of some fairly in-depth understanding of the industry if you're going to try to guide it in the direction, for example, that the U.S. government wants it to be guided.
Okay, I've got a couple more questions, but I haven't seen any questions come in from the chat box. So folks that are listening, please put your questions in the chat box. So Paul, let's get into the little trickier stuff. Taiwan and its position vis-a-vis China because of semiconductors. So Tsai Ing-wen has basically said at one point that Taiwan is protected by a silicon shield. And I guess what she means by that is China wouldn't dare invade because they don't want to wreck the plants. They don't want to disrupt TSMC. I don't know. There's any, if there were, so then I guess the question is, what do you think of that? And then if China were to take Taiwan by force, could they run these things? Could they do it? Particularly if there were sanctions there are against Russia. So take that one on.
But no, those facilities in Taiwan, TSMC, for example, are inoperable without real-time delivery of inputs from all around the globe, right? So, and Mark Liu, the CEO, has said this. I think it was during the Pelosi visit. There's no way that China could engage in some sort of military operation against Taiwan, take the island by force, and then simply continue to run those facilities if there were any kind of sanctions or any kind of damage to them. They're very sensitive to damage, of course, too. So no, the answer to that is clearly no. The silicon shield concept is a little more complicated. This is something Tsai Ing-wen and Taiwan has sort of for a long time had this position, and that's one of the reasons they've forced TSMC to keep the most advanced technologies capabilities in Taiwan. So, for example, TSMC has fabs in Nanjing and Shanghai in China, but they can only they're limited in what they can do there. They're at 28 nanometers right now. And so, the Taiwan government, for example, has kept a very close sort of watch on the industry in Taiwan in general and in TSMC in particular. So there is that sense that yes, that the semiconductor industry is another sort of factor in Beijing's calculus around the issue of Taiwan and reunification. But of course, there's many other factors. So, and this is an interesting issue because, say 10 years ago, the semiconductor industry was probably not really a factor in terms of Beijing's calculus and over what to do about Taiwan. So in the space of less than a decade, then the Taiwan issue has come to the fore, in part, of course, because the U.S. has also taken steps to cut off mainland Chinese companies from using Taiwan as a manufacturing base, particularly Huawei, right? So I mean, if you just look at it from Beijing's perspective, cutting off Huawei from TSMC, basically undercut the entire business model of your leading tech company. This was $140 billion company that after the U.S. action is now well below 100 billion and dropping fast because basically that action of cutting off Huawei from TSMC undercut their whole smartphone business, undercut their semiconductor or their telecommunications manufacturing business. All of their business lines actually relied on semiconductors that they designed and built at TSMC. So that from Beijing's optic, then now Taiwan is a critical player. So I've written quite a bit on this about this sort of unknown red line, right? Because Beijing didn't really react specifically to Huawei by taking action either against U.S. companies in China or against Taiwan. But to the extent that further there's further actions, for example, cutting off other Chinese companies from using Taiwan as a manufacturing base, that adds to Beijing's calculus here. If Taiwan is not usable, for example, by Chinese companies, then that would seem to undercut the silicon shield thing, right? The silicon shield argument. So I think semiconductors is now certainly in the mix. But again, as the Pelosi visit showed and other recent actions, the whole issue of Taiwan and China and the U.S. and where we go here is really very complicated. My argument has been that that there's a real need to rethink the documents, for example, on which the whole U.S. China Taiwan relationship are based, the three communiques, the Taiwan Relations Act, and the six assurances, because those were negotiated in a much simpler time, right, in the 70s, 79, with Jimmy Carter, and at that time the semiconductor industry wasn't an issue, but also China wasn't a military power, and the people of Taiwan, the democratic development of Taiwan wasn't there. So those three factors: China's rise as a military power, the rise of democracy in Taiwan, and the semiconductor, the position of Taiwan in the global semiconductor industry really fundamentally changed the game here. And so I would argue that there needs to be some rethinking of those documents and how that relationship is governed. But it's tricky, right? Because the U.S. China relationship is so bad that there's no trust on either side. So even thinking about how you're gonna solve this issue is really off the table, at least for the moment. We have a lot of clients, though, that are very concerned about this, right? Because of the semiconductor industry, primarily, and because any tech company of any size has some exposure to Taiwan, and so we're getting asked to do a lot of risk scenarios around Taiwan. What are what types of actions could China take that would either force the U.S. and other Western governments, for example, to sanction China, as has happened in the case with Russia, of course, over Ukraine. So Taiwan now is sort of a big part of my day because of the risks around the semiconductor industry and to the ICT sector in general. But I think that silicon shield concept, to get back to the original question, I'm a little skeptical that's ultimately China will react to external actions and the perception that the U.S., for example, is hollowing out the one China principle and is allowing Taiwan to move away from considering independence, and that will be the key consideration. But the idea that China could just sort of walk in to Taiwan, either peacefully or not, and run those fabs, I think is still kind of an illusion, because as Mark Liu and many others have said, those are sort of real time, globally linked operations that if there was for example, an air blockade over Taiwan, those fabs would be out of business right away. And so it's not conceivable that China could take over Taiwan, run those fabs in the face of any kind of Western sanctions.
Okay, so we don't have too much time left, but let's talk about the Chinese industry. So
sure.
So China, the U.S. has put sanctions on chips going to China, et cetera, like Huawei you talked about. Mm-hmm. So now China, as far as I can see, is throwing money at the semiconductor industry. I mean, there was just this past week or 2 weeks ago, there were, I don't know, 3,000 companies that were shown to be basically fraudulent. I guess they were founded to take subsidies to do something with semiconductors, but they really weren't. So tell us about what's going on with the Chinese industry. There's been rumors they can produce 7 nanometers, but then that's been debunked by other people. So what's going on there? And will China, I've seen numbers that say that they're 2, 3, 4% of the, I guess, the foundry market today. I'm not sure. And they'll be 25%, in 10 years. So what's going on with China?
That's a great, that's a huge, we should do a whole hour on just that. I did a paper last year for American Affairs. If you Google my name and American Affairs, you'll see a pretty detailed look at the domestic semiconductor industry. So basically, since 2014, roughly, when Xi Jinping and various Chinese ministries established the National IC Investment Fund, China has been trying to sort of change the way it subsidized and fostered the semiconductor industry. Before that, it was really state-run plans and state-run factories, right, which didn't really produce much innovation. And so in 2014, the National IC Investment Fund was set up, and the idea was that it would be run by investment managers, and they would pick and choose, viable projects. Now that has also proven to be problematic, as we've seen recently over the last 6 months with the arrest of many of the leading managers of the National IC Fund and some of the other investment funds for corruption. Because what happened was the National IC Fund produced some successes, like YMTC, for example, which is now a memory player in the 3D NAND market, which Apple is trialing YMTC memory for the iPhone and for the iPad. So there are certain successes coming from heavy government subsidies and support in China. But the problem is that the industry is very, very market driven. And so a government attempt to sort of, plan any element of the semiconductor industry is really almost doomed to failure. Huawei was one of the great success stories because Huawei developed, for example, a world-class semiconductor design team at HiSilicon that was as good as Qualcomm, right? It was producing designs that were world-class and cutting edge. Before, of course, they were cut off from using TSMC as a manufacturing base. So, the private sector in China, in some cases, produced really capable companies that were globally competitive. But the idea, at least to me, that the government through subsidies is going to create a competitive global industry is really, doesn't really make sense. But China now is faced with this dilemma where the U.S. government is cutting off, different pieces of the semiconductor supply chain. And in particular, for example, as you mentioned in the foundry side, the leading foundry in China, SMIC, I think it has right now maybe more like around 7% on the foundry market, but it's all more mature nodes, right? Because basically SMIC has been cut off from that advanced ultraviolet lithography equipment, and so they can't go to those smaller nodes. So they stretched their existing equipment, deep ultraviolet lithography, DUV, down to some pieces of 7 nanometers, but it's really sort of a marketing thing. It's not really true 7 nanometers. It's some layers, and it's not clear what the commercial yields are yet there, because it's really hard to stretch that equipment down to 7 nanometers and get really viable commercial yields. So that's where the doubt comes in. The industry is people you talk to in the industry who really are following this very, very closely are skeptical that this is, this is really 7 nanometers. But the media picked the story up, and so it's like, oh, China has advanced semiconductor manufacturing, but it's really a bit of a chimera because they certainly can't go below 7 nanometers, and they probably can only do very limited runs at 7 nanometers. So the problem is that IC Fund that was set up focused mostly on manufacturing. So they have tons and tons of fabs all around China, but none of them are really run on a commercial basis, right? Except for SMIC. So the problem is, if you're going to build fabs and try to manufacture advanced semiconductors, you really need a customer base over which to amortize all those investments, because you're going to have to continually invest in R&D and continually upgrade the equipment. And so in China, they sort of went with almost a state-owned mentality, or state-run mentality that, hey, let's build stuff and figure out who to sell it to later. And that's proven to be, a pretty difficult model. And the other thing that they neglected was investing in the semiconductor manufacturing equipment. So China is well behind in most of the key areas of semiconductor manufacturing equipment: lithography, etching, metrology, for example. All of these are really critical pieces of the supply chain to build the machines to make the semiconductors. And so they're behind now on the manufacturing side. They're also well behind in the making of the equipment. So there are these areas where they are good, like design. So design is a low barrier to entry, right? All you need are really good design tools, which of course is dominated by the U.S. And the U.S. is going to continue to probably control even tighter the use of those semiconductor design tools. But so when you talk about China, it's a sort of a mixed bag. They have some really good companies that are doing great design. The manufacturing SMIC is a pretty good company, but they're sort of frozen at around 14 nanometers really commercially because of the restrictions that the U.S. has imposed. And then in terms of the equipment manufacturing, they're 5 to 7 years or more behind, 3 generations at least, with a few minor exceptions. But the problem is, if you're going to be independent from U.S. suppliers or Western suppliers, you need all those pieces of the supply chain, plus you need all those materials and other things, other key inputs like process gases, that are coming from Japan. So it's really, the bottom line is that no country in the world has tried to do everything itself and to try to reproduce all pieces of the semiconductor supply chain. When I talk to leading Chinese semiconductor industry people, they get that, of course, because they're sophisticated, they get this, but they're under a lot of pressure from the Chinese government to be more reliant, self-reliant, to rely less on foreign technology. But it's expensive, and in some cases you need, it's not a matter of money. There's a lot of money sloshing around in China, a lot of subsidies. They've opened up the stock markets. A lot of companies are listing in Shanghai that are semiconductor companies, so they're raising money. But it's really not. It's not a matter so much of money as it is people and managers, really good mid-level managers who again understand sort of the commercial realities of the industry and can be plugged into the global industry. And then also the technology. You have to keep iterating the technology, and you have to develop those trusted ecosystems like TSMC did, for example. And that's really hard to reproduce in China, if those companies want to compete globally, for example. So it's likely that we will have some domestic Chinese industry that will produce semiconductors at not at the advanced level, but good enough for a lot of applications. But if the U.S. continues to cut off China, for example, from the most advanced manufacturing equipment, it will be really tough for the domestic industry to flourish. Now, the really interesting piece, to get back quickly to your TSMC question, is as long as Chinese companies are allowed to use TSMC to manufacture advanced designs, it somewhat doesn't matter that SMIC can't do that. So that's going to be the sort of where the rub is over the next 6 months to a year, is does the U.S. continue to try to cut off Chinese companies from using TSMC? Because it's sort of a weird situation that I've highlighted in some of the things I've written on this, that even as domestically the leading Chinese domestic foundry can't get access to that advanced equipment, many Chinese companies are still using TSMC to manufacture semiconductors. And so that would seem to be sort of an inconsistency in U.S. policy, what's the goal of U.S. policy here? Finally, I mentioned earlier we were discussing this idea of cutting off GPUs. So the most recent development is that over the last 2 months, the U.S. Commerce Department has sent letters to companies like NVIDIA and AMD, basically saying you're going to have to stop selling your GPUs to China. And this is a huge, huge development because those GPUs are used for high performance computing and for AI, to run AI workloads, for example, in the cloud. And many, many Chinese companies use those semiconductors like Baidu Cloud and Alibaba Cloud. And so over the next, again, 3 to 6 months to a year, we're going to see the U.S. Sort of tightening controls over specific categories of semiconductors, and then the domestic industry in China is going to respond to that. So we're already seeing a lot of Chinese GPU companies, for example, coming to the fore, getting more investment. But again, that's going to be a long-term process for them to really reach the technology levels and the sort of commercial, gravitas that companies like NVIDIA and AMD have built up over the years. So the domestic industry is going to get better, but it's going to be a long haul, and it will depend in part on how quickly the U.S. moves to restrict some of the key inputs like equipment and like specific categories of semiconductors.
Yeah, so, someone in, and I don't know who the author was, in Foreign Affairs had an article recently, and was saying it was somewhat analogous to cutting off oil to Japan in the late 1930s. If you're going to cut off China from all these things, you're giving them more of a argument to say, well, they need to maybe take over Taiwan or something. So I've seen that argument going around recently, people talking about this.
Yeah. I mean, that's an argument I looked at it. I did an article for IISS looking at sort of the impact of continuing to restrict Taiwan and what that does to the security situation in East Asia.
Right. Okay, so we've gone, well, we're 5 minutes past our hour. I'm surprised I don't see any questions. I know there's some folks on here that have some familiarity with the industry. But I guess, here's your last chance if anybody's got something they want to put in the chat box. I've been very impressed again, Paul, with your knowledge. Obviously, we could talk a lot longer on this subject, but our time's coming up. But I think I found it really fascinating. Yeah.
Yeah, I mean, we could cover just the Chinese domestic industry as a whole separate thing, and then we didn't really go too much in depth in terms of the U.S. Sanctions and export control. What the goal of all that is, and that's another key piece of this, and that's evolving, as we speak.
Right. Okay. Well, if there are no questions, Mon, do you have some closing comments besides thanking Paul for his time?
Well, yeah, that too, and also just thank you everyone for joining us, and also as I mentioned before, at the beginning of the webinar, so do check our website for future events. And the next one will be Wednesday, the day after tomorrow, on Uyghur Forced Labor Prevention Act.
Thank you.